The challenges of operating in deep space continue to push limits and amaze scientists. This trip is about strength, what we can learn, and how humans never stop wondering. Here's something really interesting. This spacecraft is super far from where it started. The signal Voyager 2 picked up wasn't just random. It had a pattern, showed up at certain times, and repeated. It was a hidden message from far away. Now, scientists are trying to figure out what it means. Could it be new stuff we don't know about in physics? A structure in space? Or something on purpose? Whatever it is, this strange signal has changed what we thought we knew about what's past the heliopause. Out in space, there was a weird ping. At first, people thought it was just noise. Voyager's tech is old, and its power source is getting weaker. Over time, engineers have learned to spot things like heat changes, weak signals, and space stuff getting in the way. But this signal didn't look like any of those things. It had a certain pattern, timed pulses, and a signal difference that no one had seen before. Dr. Catherine Yao, who leads the mission at JPL, looked at the signal. It wasn't just odd. It seemed on purpose. It wasn't acting like a simple problem. It was too perfect. Other checks showed that this wasn't the only time it happened. Similar signals had been seen in March and April 2025, but people thought they were just background noise. When they checked again after this event, they saw the signals had the same signature: tight, rhythmic, and clearly not random. What made the signal on May 14th so important was when it happened. It showed up when they were firing the thrusters as a normal thing. Voyager's system for staying in the right direction had fired to turn the antenna. This is something that needs to happen every few weeks. The signal came just seconds after, which was too close to ignore. Now, people have a theory. Maybe Voyager isn't just sending signals, but it's also a sensor. Some physicists think the spacecraft might be interacting with space stuff in ways they never thought about. Maybe its thruster is messing with magnetic things or touching a plasma layer, which shows a special space vibration. It's like tapping a glass in a quiet room, said Dr. Sanjay Malik from ESO. You only hear something when everything is perfect. Voyager might be ringing a bell we didn't know was there. To check things out, NASA is planning to fire the thrusters very carefully. They'll make small turns and watch them from all 3 stations of the Deep Space Network, DSN. They're also writing new computer instructions to quickly spot any weird things. At the same time, they're linking together a bunch of places that watch space schools, the military, and others, to make sure they can all see the same signals. For a spacecraft that's been going for longer than most people have been alive, this is a big change. Voyager 2 might not just be an explorer. It could be the first thing that can really hear what space is saying. But a signal is only as interesting as where it comes from. And that's what happened next. When engineers took the signal from May 14th apart, they found something no one was expecting. A repeating pattern hidden in the X-band. It wasn't information, thrust, or an echo. It was something they couldn't figure out. Voyager had spoken, but in a language they didn't understand. Now, they had to figure out not just what it was, but what it meant. The next part of the search would make the mystery even bigger. This signal was not what anyone expected. When the data engineers removed all noise, what was left wasn't data. It wasn't the sounds of the power system, the RTG, or the control system. Deep inside the X-band, at exactly 8.4 gigahertz, was a repeating pattern. It was a small change in strength that went back and forth with perfect timing. It didn't match anything Voyager's systems make, and it repeated at certain times, which made it seem like a signal, not just a random thing. Computers checked it, but they said it was a low-level issue, maybe just a new kind of space plasma change. But engineers looked closer and saw it had a rhythm, with waves about 0.71 seconds apart. That's too exact for just noise. It wasn't data. It wasn't natural, and it didn't match space signals like pulsars or solar radio bursts. Simply put, it didn't belong. This wasn't a mistake, said Dr. Olivia McCoo, who leads signal research at Caltech's Interplanetary Data Lab. This was planned, even if it wasn't planned in a way we know. Either we're seeing a new thing in nature, or something is creating the field we're seeing. It wasn't a message, but it wasn't silence either. In late June 2025, the signal showed up again. DSN teams had planned a thruster test, and Voyager's direction was adjusted a bit. About 2 minutes later, the same pattern came back, but with a slight change. The signal was changing, growing, reacting. Engineers checked all the records. No data problems, no wrong commands, no system errors. Whatever it was, it didn't come from Voyager. It came through it. By July, the Voyager task force was created. It was a mix of radio engineers, plasma physicists, and astrobiologists from different space groups. Their job? Figure out if this signal was made from space or something else. And if it was something else, what had Voyager become? A receiver? A trigger? Or just a messenger between places we've talked about? But even patterns start somewhere, and patterns with timing have to come from something. The next question wasn't what the signal was, but why it was showing up after the thrusters fired. As the team looked deeper, they saw something strange. Every big signal happened when Voyager changed direction a bit. Could the spacecraft's movement be creating what it hears? Could it be disturbing something we can't see? That question led to one of the most exciting ideas in the probe story. Was it a pattern or a pulse? Voyager's thrusters don't fire often, usually every few weeks to stay locked on Earth. But after the signal came back during 2 direction changes in June and July 2020, engineers made a connection. Every time the control system realigned the antenna, the signal came back, not randomly, but within 90 seconds. Voyager wasn't sending it. Voyager was waking something up. This led to an interesting idea. The probe's thrusters might be touching something in space. Maybe a magnetic thing, space wind, or a wave that we can't see until it's moved. The thruster's exhaust, even though it's weak, might be ringing something like a bell in space. We think of Voyager as just watching, said Dr. Romesh Karni from Caltech. But what if it's playing a role in something larger? A lens? A tuning fork? Or even a trigger? To check this, NASA planned a thruster test on August 5 RD. Voyager was told to make a small turn, just enough to change position without changing course. The result was fast. Within 58 seconds, stations saw the same pulse, but now with a second part. Not only was the signal back, it had grown. More studies showed that this new pulse had a frequency split, with 2 bands moving together, but timed differently. This dual pulse wasn't known in space. It didn't match anything. We've never seen this, said Dr. Ayumi Kondo from JAXA. It's not just new, it's reacting. Something is responding to movement, not just mass. Some people started thinking about stranger things. Unknown fields, space structures, or different physics. But most held back, remembering that big claims need big proof. But the fact was that each test repeated the pattern. Something was acting with timing. Science does well with things that repeat, and Voyager signals were doing just that. A mystery was building, not as a random thing, but as a repeating interaction between a spacecraft and its space. If it was natural, it was a new kind of space structure. If it was made, then Voyager 2, the oldest mission in space, had come across humanity's first space message. The results would change what we know about space and how we build things. The signal connects to thruster events. By mid-August 2018, it was clear. Every time Voyager 2 adjusted its position, the signal came back. The timing wasn't random. Engineers mapped each signal to the craft's records, finding a delay of 42 to 65 seconds after the thruster fired. The signals weren't random. They were predictable and connected to Voyager's movement. Voyager's control system uses the thrusters to keep its antenna pointed at Earth. Usually, these changes are hard to see, except for a small change in signal strength. But each time, a structured pulse came not from Voyager's data, but from the signal itself. The teams called it a reactive pulse. We've never seen a spacecraft talk back to space like this, said Dr. Meredith Hale. It's like Voyager is echoing through something, not sending, but vibrating. And it's listening and answering. NASA planned a series of thruster firings with careful signal watching. The August 5 RD test, which caused the dual signal response, was repeated on August 11th with a similar movement. The result was a mirrored signal, the same but flipped, showing that the spacecraft's movement was shaping the return. This changed how people talked about it. The signal was seen as a field interaction event. Voyager wasn't just receiving or disturbing. It was acting as a space resonator, a probe of both space and how space acts. The thrusters weren't changing Voyager. They were changing the space around it. That changed the question. Was the signal a response or a natural effect? Was Voyager setting off something special or just showing something already there, like fog in a light? If movement activated the signal, then space itself might have things we haven't seen. Either way, it made scientists rethink what Voyager was flying through. The answer could change what we know about space. New physics or a space surprise? Since 2012, Voyager has been going through the interstellar medium, ISM, the space between stars. It's a place we don't understand well, only mapped by ideas. But the signals suggested that space might be more structured than we thought, a place with many interactions. The signals didn't fit anything. They weren't pulsars, quasars, or solar. Voyager had left the Sun's area in 2018. Instead, physicists looked at the magnetic field and Voyager's power source. Could the radiation be touching the plasma or disturbing a magnetic structure? This could be a huge discovery, said Dr. Leila Navarro. We may be looking at a natural layer that reacts only under certain conditions. Some think of plasma waves that become bigger with spacecraft movement. Others think of remains from stars. But Voyager 2 was recording what no telescope could see. The results are big. If the signals are natural, they show new structure. If made, it's more surprising. But even if natural, it means missions could be designed to listen to space itself. NASA is making models of how this might happen with magnetic waves. Researchers have joined the effort. Voyager, still speaking, keeps going through space. The signal's nature was one thing, but proving where it came from was another. Was Voyager making the pulse, or was it just a lens? If it was an amplifier, it would need to be sensitive. And could it be natural, or was something answering? The signal had been checked. Now the work began, testing the spacecraft for problems or confirming the impossible. Before announcing anything, NASA had to rule out Voyager. Could a problem be injecting false patterns? Voyager 2 was launched a long time ago, and some parts are older than the people studying them. If the signal was just noise, the mystery would end. The first step was to check the control system and the data path. Engineers checked signals with records, temperatures, and power. There were no problems. The systems were working. Also, the timing of the pulse didn't match internal noise. It matched movement. The spacecraft was quiet. The signal was from beyond it. The next test was to copy the signal across stations. If something was causing the signal, it would be different at different sites. But the signals matched. The source was real, not from Earth or software. To go further, NASA asked ESA to study old data. They found signals like the ones from 2025 from earlier years. Not as clear, but there. The patterns had always been there, becoming stronger when Voyager crossed a path. We have to be careful, said Dr. Emily Tarasova. Before we say it's real, we have to rule out ourselves. So far, Voyager is stable, the transmissions are stable, and the signal is external. With failure ruled out, scientists focused outward. If Voyager wasn't failing, it was detecting. The next step was to work together. A spacecraft had picked up something real. Now, there was a race to see what it was. Voyager 2 wasn't just old. It was a signal flare. In late August 2025, the story spread. What started as a simple question had become important. Teams from different countries scanned with radio telescopes. Universities looked through old data. It was a global effort started by the oldest spacecraft ever built. Early data showed similar pulses. These weren't confirmations, but they hinted at a wider area that stretched across space, only seen when disturbed by a spacecraft. The signals were weaker, but real. Journals reacted. Writers finished articles. At CERN, people argued if the signal could be special matter or plasma waves. Conferences added discussions. This might be the moment we've waited for since SETI began, said Dr. Jonah Reeve. It might not be intelligence, but it's smart to ask. People got excited. Social media talked about Voyager, a spacecraft older than the internet. YouTube channels broke down the signal. Downloads of Voyager's data increased. NASA held a press conference. We don't know what this signal is yet, said leader Karen Fields. But we know what it is not. It is not Voyager's failure. It is not random, and it is not something we can ignore. The message was clear. This wasn't just one issue. It was a worldwide moment of listening. The world listened. It was a moment when Earth looked out and heard something looking back. And maybe for the first time in a long time, science was brought together by a mystery. These signals cracked open new ideas. For years, scientists have wondered how to talk across space. But Voyager May 2nd have found a new way. Not by sending, but by resonating, by using movement. What if spacecraft don't just listen, but become part of a signal? Said Dr. Nora Johnny. The results for future probes are big. Missions may need to carry instruments to feel how space is. NASA has started putting these ideas into plans. The Voyager signal could change how we explore. But every signal makes us wonder, is it nature or intelligence? Could Voyager be finding physics or presence? With the motion connection, many are asking if we're seeing nature or if we're being answered. The phrase intelligence was whispered. Scientists don't like the word unless it can be proven. But with Voyager, there was rhythm, response, and change. What kind of system responds in time? The SETI Institute joined the group, bringing tools to find artificial signals. While the Voyager signal wasn't digital, its pulses had order. There was regularity. At least 3 times there was order. It wasn't chaos. The idea of intelligence without language started. Maybe not beings, but systems reacting to interference. Some wondered about an ancient construct, triggered by Voyager. As strange as it was, people stayed focused. To keep theories calm, NASA wanted multiple checks. Voyager 1 was re-examined. While similar signals were found, no rhythms matched Voyager 2's. This meant the motion idea was stronger. Maybe Voyager 2 had gone through an area that Voyager 1 had missed. The focus had changed. The question, "Are we alone?" was being asked through a spacecraft moving quietly. So, if it wasn't a mistake, what's next? Scientists faced a hard thing. What do you do when the universe might be speaking, but you don't know the language? NASA and others prepared Voyager 2, not just as a watcher, but as a participant. What's next? The first rule: test again. Starting in October 2025, NASA planned thruster firings with signal watching. They were signal experiments to repeat the signal under different conditions. NASA and partners started making a computer update to the DSN code that would flag signals. If another signal came, the system would catch it live. Cooperation increased. A group was formed with scientists, engineers, and others to study the signal and prepare for what's next. Whether the signal is weather or a message, it has set something up. Voyager 2 has become part of something larger. This is no longer about what Voyager was, said Dr. Maya Ellison. It's about what it has become and what role it may play in our understanding of the universe. Future missions may need to activate, to ask. Voyager may have done that. It disturbed the space and something answered. Voyager 2 was supposed to go silent. Instead, it spoke back. In May 2025, NASA saw a mysterious pulse after the probe moved. A signal no one expected. Not a mistake, but a response. As researchers rush to decode it, it's clear. We may have found a way of talking older than us. Space isn't quiet, it responds. Voyager just proved we haven't been listening right.